Hello, everyone. Welcome to the day 3 of CCIP Bootcamp. My name is Andre. I'm a developer relations engineer here at Chainlink Labs. And today I have Darby Martinez with me, your main instructor for day 3. I'm gonna quickly start sharing my screen just for a minute to do a small recap of yesterday. And if you have any questions, feel free to drop in on chat. I will try to answer those before we start, and then we're gonna kick off with the content for day 3. Speaking of content for day 3, you will need USDC on Avalanche Fuji for this day. We already mentioned that twice, so if you haven't if you have not gotten your USDC on Avalanche Fuji tokens, please do that. So here is the link to the official Circle faucet. So faucet.circle.com. Go here, click the Avalanche Fuji, put your wallet address here, and hit send 10 USDC. Or if you have any issues with this faucet or official Chainlink faucets at Chainlink and faucets.chain.link, you can always go to the setup instructions over here and click on this URL to navigate to the Bootcamp faucet, where you will just need to enter this password, capital B, capital M, Big Mac 777, connect your wallet, select the appropriate network, and grab your testnet tokens for today. If you missed any of the previous classes from day 1 or day 2, you can always go to the official Chainlink YouTube channel at youtube.com/@chainlink, like literally @chainlink. Go to the live tab, and over here you can find the replays from day 1 and day 2. And also this video will be available on demand. It's live now, but will be available on demand immediately once we're done with the content for today, so you can always revisit it. This is also the last day, so this is 3-day bootcamp. This is your last day. No more classes after this bootcamp, but there is homework. So again, deadline for homework is August 25th. So again, day 1 homework, you have 15 questions, 5 easy, 5 medium, 5 hard ones. If you have any questions about homeworks, drop them in a chat. Now, for day 2 homework, if you remember, we had a homework, like a coding assignment using Chainlink Local to write one tiny single unit test in Hardhat or Foundry, if you prefer, using Chainlink Local for the project that already has contracts and everything. So that should be like pretty simple and fun, hopefully. And for today's lecture, you'll also have day 3 homework, but more on that later. Speaking of today, curriculum, if you complete all your homework assignments, more precisely, at least 80% of your homework assignments, you will earn this certificate of completion, and you will be ready to confidently put CCIP as a skill in your resume. So speaking of curriculum, we have a little bit of theory today. We're going to talk about 5 levels of cross-chain security that comes with chaining CCIP. So that's some design patterns and decisions used to build chaining CCIP. And then we'll have an exercise where we're gonna transfer USDC using chaining CCIP, and then Darby will try to inspire you how you can then use these primitives to do more complex DeFi stuff on various different blockchains using CCIP, like, I don't know, supplying to this lending protocol or borrowing there or swapping there or whatever. So this should be pretty fun. And obviously we'll have day 3 homework. So yeah, I'm gonna now welcome Darby to introduce himself to you guys. And then we're gonna just cover some other stuff before we start with the main lecture.
GM friends, how are we doing today? Let's get some GMs in the chat. My name is Darby Martinez. I am a developer expert, so I help out with technical events. And today we are working through the 5 levels of cross-chain security using Chainlink CCIP, and then we will be moving USDC across chains from Avalanche Fuji to Ethereum Sepolia today. So we'll be walking through all that in a little bit. GM, friends.
Fantastic. So that's Darby. He'll be with you today for the next 2.5 hours. So if you have any questions, obviously drop them in the chat. Darby will try to answer them live, or myself and Richard will be in the background also answering questions if needed. By the way, Darby, have you been to SmartCon before?
I have the last 3 actually. So the last 2 in person, and then even the digital one from during like 2021. All of them absolutely fantastic. So last year was in Barcelona, and the opportunity to meet with industry leaders along with the Chainlink team and everybody involved was a great opportunity for me and so many others that were in attendance. And then the year before that in New York, same thing. Just an absolute awesome experience. And I'm looking forward to going to Hong Kong this year, having a little bit of a travel experience in Asia personally. So being able to draw on some of those skill sets, but also kind of get out and learn some new things. Yeah.
That'll be great. So yeah, guys, if you want to also join the SmartCon in late October and potentially meet Darby there, but also like more importantly, like listen from the industry leaders, sign up here. So you can register clicking on this URL or scanning this QR code. And also, as we mentioned yesterday, there will be 2 days prior to the main event, Hacker House. This is an event specially crafted for developers, for you guys. And also another thing for you is this tokenized RWA Bootcamp. Is it available for signups only for you? It's not live yet. It's just for the participants of this CCP Bootcamp. So once again, register either here, clicking on this URL or scanning this QR code. It's going to be hosted from September 3rd to October 2nd. We're going to use multiple different Chainlink services to tokenize real estate and mock real estate, and then we're going to use that tokenized asset for various different purposes, to get loans in USDC, to fractionalize it and sell it to other counterparties, and much more. So make sure to sign up for that one. This one is going to be, again, similar to this one, like intermediate to advanced level, and CCIP will be a huge part of it. So this bootcamp is actually a really good prerequisite for this one. So over here you'll find about more details about what you'll learn about that one. But again, I'm gonna mention that repeat that this one is going to be intermediate level to advanced, similar to this one. Cool. Finally, if you have any further questions about content or homeworks or whatever, after today, we have a dedicated channel at Discord, Chainlink's Discord, called Bootcamp, I think. So ask questions there, tag us on socials, on Twitter. You'll find at Meet Our Instructors page details about our social networks, where you can find us, and emails, Darby's Twitter, Darby's LinkedIn. So if you have any questions, drop them first in Discord. If not, you can tag us on socials. And yeah, that's pretty much it. Good luck. I'm gonna stop sharing my screen. And Darby, the floor is yours.
It's my turn to share screen?
If you want.
Kidding. Yeah,
you can share it.
Share screen.
We can see people from Greece. Oh, that's cool. GM, guys. Cool. I'm just gonna remove myself from the stage. Darby, the floor is yours.
All right, so I am going to move this discussion over to a presentation that I prepared, but I want to go ahead and make sure that it is known that the source of truth on the 5 levels of cross-chain security with Chainlink CCIP is within the Git book. You will find it on day 3. It's the first tab within day 3. And then all this information, I basically just distilled to talking points so we could have a easier flow on the presentation, but I'm going to move that right over to this presentation here. So CCIP Bootcamp, level 5 security, and then we're going to be transferring USDC. Once again, my name is Darby Martinez. I'm a Chainlink developer expert. So what is level 5 security, or defense in depth? Level 5 cross-chain security brings unprecedented decentralization. It relies on multiple decentralized Oracle networks working together, which creates no single point of failure. The risk management systems are proactive identification of potential threats and a rapid response capabilities, which have key features of emergency shutdowns, quick response to severe threats, and then rate limits prevent large-scale unauthorized transfers. And then, as you can see here, the first level of security would be centralized, and within a centralized system, there is one source of failure, and then a decentralized theater, or the decentralization theater is the next step. Then one network would be slightly more secure, where then multiple networks is slightly more secure. But when you get to the 5th level, you have a committing DON, the risk management network, and the executing DON, all working together and all different to make sure that the data is secure, verifiable, and usable on these networks. So CCIP's multi-network approach has multiple independent networks, not just one, but several networks secure each bridge. It's composed of independent nodes working collaboratively. The contrast with traditional bridges, many bridges are a single node or multiple nodes under one key holder, whereas CCIP is multiple independent nodes with separate key holders. Then 2 distinct node groups. There's the transactional DON nodes, which handle the executing or the committing. And then you have the risk management network nodes, which are in the middle there, securing the data and information going across. Then it has unprecedented client diversity, 2 entirely separate implementations with independent code bases, and results in unparalleled decentralization for cross-chain interoperability. The key information on the separate code bases is that so Andre, maybe you can clarify, but I believe some of the nodes were built using Golang, and then other networks were built using Rust. And I believe, can you elaborate on the difference between the 2 code bases and the transactional DON and the risk management network nodes?
Sure. Yeah, you answered correctly. So there is 3 offchain components, 3 DONs. DON stands for Decentralized Oracle Network, committing DON, executing DON, and risk management network. One node can be part only of one DON, so you cannot, cannot be part of like 2 DONs or 3 DONs or whatever. Each of these DONs are doing different part of the work to make Chainlink CCIP secure. Risk management network is like the next level of securing, basically overlaying the whole process. And yeah, node clients for committing DON and executing DONs are written in Go. The node client for risk management network is written in Rust, actually, using exactly the same specs, but different languages also to minimize risks from bugs or issues in the client implementations itself.
All right. Thank you for clarifying that, Andre.
You're welcome.
Now, what is level 5 security or defense in depth? Developed with security and reliability as the primary focus, CCIP operates at the highest level of cross-chain security. It's CCIP's defense in depth, security, and suitability can be broken down into 4 categories, and I'll go over each of these categories. Multiple layers of decentralization, the risk management network, high quality node operators, and configurable rate limits. The multiple layers of decentralization at CCIP. So the foundation, it's built on Chainlink's proven decentralized Oracle infrastructure, and it avoids a single monolithic network structure. The decentralized Oracle network, or the DONs, there's multiple DONs per chain lane. Each lane has a unique source chain and destination chain. This enables horizontal scalability, and new DONs are added for each supported blockchain. So the committing DON monitors events on the source chain, waits for source chain finality, bundles transactions into a Merkle root, reaches consensus on the Merkle root, and then commits the Merkle root to the destination chain, where the executing DON submits the Merkle proof on destination chain, verifies transactions against committed Merkle root, and then validation by the risk management network. You can see this figure is also within the Git book itself, where it explains the relationship between the Merkle root and proof. But then the key kind of information here is that the CCIP message flow is the message is finalized with the Merkle tree on the source chain, and the Merkle root is published on the destination chain. Next, we're on to the CCIP's risk management network. It's a separate, independent network which continuously monitors and validates CCIP behavior. It provides an additional security layer. The technical implementation is that there's minimal Chainlink node software implementation. It is written in Rust versus Golang for primary CCIP system. It's developed by a separate internal team, uses distinct non-overlapping set of node operators. The client diversity, it increases your robustness, minimizes external dependencies, and prevents supply chain attacks. Then there's two major points to this with secondary approval and anomaly detection. So secondary approval independently recreates Merkle roots, publishes on the destination chain, compares with the committing DON's Merkle roots, and then the cross-chain transactions require matching Merkle roots. The anomaly detection monitors for abnormal CCIP network behavior, checks for unusual chain behavior, like deep block reorganization, and can trigger emergency halt on all CCIP lanes and limits potential losses from suspicious activities. And then this is a figure to help you visualize the end users to the risk management network, the on-ramps, the routers, the committing DON, the executing DON, and the flow of a CCIP message. You can also find this within the Git book. Then we are going on to the CCIP's high-quality node operators. So an operator characteristic, they're geographically distributed, meaning they're not in one location. They're Sybil resistant, security reviewed, experienced in mission critical infrastructure, both Web 2 and Web 3. Notable operators on the global enterprise side of things, you have Deutsche Telekom, MMS, Swisscom, and Vodafone. Leading Web3 DevOps team like Infura and Coinbase Cloud, and then also experienced Chainlink ecosystem projects. Network composition commits, you have the committing and executing DONs, which are composed of 16 high quality independent node operators. And then the risk management network has 7 distinct node operators, and in total 23 node operators. The risk management network is separate and non-overlapping set of nodes. So they're independent from the transactional network. And it ensures independent secondary validation. The scalability, the number of operators can increase as CCIP secures more value. It adapts to growing security needs, allowing you to scale horizontally. Now on CCIP's configurable rate limits. The purpose is the additional layer of security for cross-chain token transfers and prevents large-scale unauthorized transfers. The implementation, configurable limits and established on 2 levels, per token basis and per lane basis. The alignment with stakeholders, rate limits set up in collaboration with token contract owners, ensures limits are appropriate for each token's ecosystem. They can aggregate the rate limit with applied across all token pools on each lane, which provides an extra layer of security. And then in the worst possible case scenarios, you have impossible to max out every individual token's limits, and the aggregate lane limit acts as a final safeguard. The limits can be adjusted as needed, and it allows for adaptation and changing market conditions or security requirements. And in conclusion, multiple independent nodes are run by independent key holders, 3 decentralized networks, all executing and verifying every bridge transaction, separation of responsibilities with distinct sets of node operators, and no node shared between the transactional DONs and the risk management network. The increased decentralization with 2 separate code bases across 2 different implementations, written in 2 different languages, to create a previously unseen diversity of software clients in the bridging world, and never before seen level of risk management that can be rapidly adapted to new risks, attacks, or changes. And then all of that can be found. Sweet. There we go. All right, all of that can be found within the Git book, which is provided here in this YouTube, and then all of our resources here. And if you want to read further into all of that information, once again, I took information from this Git book and distilled it into just the talking points to give to you guys. So this is the definitive source of truth on all of this. So if you want to dig in a little bit further, read it, understand what's happening underneath the hood, all 4 of the pieces to CCIP's defense in depth, you can read even further within this Git book. Highly recommended. And to understand what's happening underneath the hood, you should do this. I believe next is going right into the sending USDC across chains. So I'm going to pose a question to the attendees and make sure that we were able to access the faucet for the USDC, and that we have Avalanche Fuji and then link on Fuji as well. Because we're going to get started. So sending USDC across chain. We're going to get started. You can use it a few different ways. We have access to Hardhat and Foundry that you can use as starter kit to get this going, but we will be working within Remix. So I already have Remix open here. What we're going to do is create a new workspace. So within this, you're going to want to click Create New Workspace. There's a link to my presentation at the top of the Defense in Depth in the Git book. You can see it right here. It's even titled Darby's Deck. Back to USDC. So remix.ethereum.org. You want to pull that up. You want to create a new workspace. Create a blank project. Call it CCIP Workshop 3 or Bootcamp. I'm going to call it CCIP Bootcamp. Then what we're going to do is create an empty file, .empty.sol. I'm going to go back to the Git book here, and we need to pull in the Chainlink contract CCIP npm package. Now in Remix, how we would do that, we need to create a new Solidity file, paste the content provided here, which identifies the Solidity compiler, and it imports the client from the Chainlink contract CCIP client.sol, and then it imports the reentrancy guard from OpenZeppelin, and then it's contract empty. We're going to copy this. We're going to paste this here. Now notice on my left side of my file explorer, it is fairly bare. You have the artifacts, the prettier.json, and then you have my file empty.sol. When we paste this here and then compile it, I have mine on auto compile. But when it compiles, you will see that the dependencies with the npm Chainlink contract CCIP files will all automatically load within the file explorer. You will know you correctly did this when you have when your file explorer looks like this. Now, the next part, a little bit tricky. This contract expects at least 0.8.20 version of the Solidity compiler. It is very important to understand that with the latest Remix IDE release, the default EVM version is set to Cancun. A new opcode, push O, was added to the Ethereum virtual machine in the Shanghai update, which happened prior to the current Cancun update. Essentially, what we want to do is we want to downgrade the Ethereum virtual machine version to the Paris instead. So what we're going to do is we're going to set the EVM version to Paris, navigate to the Solidity compiler tab, and then I'll walk you through it myself. So we're going to injected provider. No, we're over here in the Solidity compiler. So we want to make sure that this compiler is 0.8.20 plus commit A1B79DE6. You'll see it is slightly down low. When I first did this in preparation, my latest local version was something along up here. So you're going to want to scroll down until you find 0.8.20 plus commit A1B79D. And then you're going to go to this EVM version. It's going to be at default. You're going to want to fix it to hit Paris. You get some thumbs up in the chat if you're following along. And then compile it. From there, you should see that the CCIP contracts and the Open Zeppelin contracts will populate. Let's close that. Let's close that. All right. Next. We have both of the faucets. If you do not have USDC on Avalanche Fuji, you may want to go to faucet.circle.com, just like Andre had you do at the beginning of this workshop and possibly in the past few days. And then if you have other problems with it, you can go to faucet.chain.link/Fuji and then click the fields that you need, like Avalanche Fuji with drips 25 link and drips 0.25 AVAX. Make sure that you have those. Cool. Jen said we did the same yesterday. So next we're going to develop the transfer USDC smart contract. Nope, wrong button. All right, back to this. So we're going to copy this body of code right here. We're going to place this in a new file called transfer USDC.sol. And then we're going to paste this in. I'm going to take a moment to kind of go through a little bit of this code, help you understand it. So we have pragma solidity, which is identifying the compiler for Solidity. And then we have all these imports. These imports include the iRouter client, the owner is creator, the client, the IERC20, and then safe ERC20. So you'll see that some of these come from the Chainlink folders, client, software, folders. Yeah. All right. So then the contract transfer USDC is the owner is creator. It is using the safe ERC20 for IERC20. And it has some error handling, which not enough balance or destination chain is not allow listed, or there's nothing to withdraw. And then you have some variables, making sure that they're private and unchangeable, like the iRouter client. The iRouter client being private, immutable, and then going to the ICCP router, the IERC, same thing for iLink token, and then the USDC token, allowing us to know. Yeah, all right. Then you have the mapping where you're doing a UNT64 to a bool, which is changing the allow listed chains. Can I zoom in a bit? Absolutely. That a little bit better for everybody to see, or should I zoom in even more? The modifier and error handling ensures that the destination chain is whitelisted. And then you have the event with USDC transferred, the message ID, destination chain selector, the receiver, the amount, and CCIP fee. You have the constructor, which is initialized at the beginning of this contract. So what we're doing is we will be identifying the CCIP router's address, the address of the link token, and the address of the USDC token when we deploy this. You have the function, which is allow list destination chain, which we will be going through. You have the function of transfer USDC, which we will be using to send our USDC from Fuji to Ethereum Sepolia. CCIP fee. And then you have the send CCIP message. The emitting of the event with that the USDC was transferred, and you have all these variables within it. And then you have your withdrawal function. I'm going to zoom out just so I can see. Hold this open. I'm going to lower these. All right. So the next step, we're going to prepare for deployment. So the next thing we want to do is make sure that our environment in our fourth tab, deploy and run transactions, is set to injected provider MetaMask. When you click this, it should open up your MetaMask and allow you to see and connect, silent message, connect to Remix. You want to make sure that you're on the Avalanche Fuji network, which is identified at 43113. You can also change that by going here, but if you do not have it, you can go to chainlist.org and then search for Avalanche Fuji. You can find that information right here within the Git book. So chainlist.org, search for Avalanche Fuji. Once you see the network with the chain ID of 43113, you click add to MetaMask. It'll ask you to sign in button and you're good to go. So from there, we're going to get ready to deploy the transfer USDC to avalanche.fuji. So what we want to do is we want to open transfer USDC file, navigate to the Solidity compiler, make sure it is compiled, deploy and run the transaction, select injected provider MetaMask, make sure we are on Avalanche Fuji. And then under the contract drop-down menu, make sure that transfer USDC is selected. So I will walk you through that right now. So transfer USDC here, contract, transfer USDC dot sol is selected. Then we're going to have this deploy tab. You're going to notice it's grayed out. And it's grayed out because it is requiring parameters from our constructor to be able to deploy. What we want to be able to do is we need to be able to tell our contract what the address of the CCIP router is, what the address of the link token is, and what the address of the USDC token is on the Avalanche Fuji chain before we deploy this, so it even knows what to point to begin with. So when you click this, it'll open it up, make it a little bit easier to identify and post this information. So CCIP router, we're going to just go right to the Git book. We're going to take this value, OXF69, as the CCIP router. Just make sure we double check and we're grabbing the right information and putting that there. And then paste that right here into the CCIP router and deploy. We're going to do the same with OXOB9. I'll show you how to import the USDC into your MetaMask in 1 second. Then you have OX542589 for USDC token right here, which is actually perfect because I needed that to be able to show you how to import it. So open your MetaMask. Say your MetaMask isn't showing that you have USDC there. You're going to want to go to your tokens, import your tokens, take the token contract address. Luckily, we just copied this from the Git book to place it here in our contract. So take that token address, paste it here, then it should auto-populate with the name of the token symbol, and then how many decibels this token has. So then you'll see that I have quite a lot of USDC. Import, and then you'll see that it'll show up within your, yes, I can, absolutely. I don't know if I can zoom in, it won't let me zoom in the MetaMask, unfortunately. Let me see. Yeah, that's zooming in is not working on MetaMask. However, when you open up your MetaMask file, on the left of your 3 drop downs, you'll have token, NFTs, and activity. You want to go to tokens. At the bottom of your tokens page, you're going to see 3 options like import tokens, refresh list, and MetaMask support. You're going to want to click import tokens. You're going to take that. You're going to open this up. It's going to prompt you for the token contract address. There's a few ways to go about this. You can go search different block scanners. You can go to docs.chain.link to get the token contract address. But for us, our token contract address was right here for the USDC token. We were given the token contract address to our contract, our transfer USDC contract. And then we're posting that here. So that then once we have the CCIP router's address, the link token address, and the USDC token address, you can transact. This one will let me zoom in. All right, so then it's asking me to confirm. And now we're waiting for the creation of this. You're going to see the deployed contracts populate on the bottom left of your remix. And then it'll open up a little folder file, pick your word. However, you can see everything and the content of your contract right here on the bottom left once you're deployed and unpinned. I'm just going to pin this contract because I've had presentations in the past where I refreshed my page and then I lost these pinned contracts, and then I had to dig into Etherscan or Avalanche Snowscan and then get the contract address and then re-import it in. And just to stay away from that hassle, I'm pinning it here. If you want to go ahead and pin it, it'll make sure that if you refresh the page, or if anything happens to Remix, you'll be able to get back your deployed contract here. Our next step is we're going to call the allow list destination chain function. So that's this one, the second function within our transfer USDC contract. So allow list destination chain. So we're looking for a destination chain selector. Then we need an allowed, and it is a bool value. So that can either be true or false. And the destination chain selector probably is a group of numbers that identifies which chain we're going to. So within the Git book, you'll find on step 2, we have both of these parameters or values already added here. So 160, 152, etc. is the CCIP chain selector for the Ethereum Sepolia test network. So we are going to copy this value. Then we are going to paste it in our destination chain selector. Then we're going to take this, I'm going to write out true. Make sure it is lowercase just to avoid issue. You copy and paste this true right here onto it just to make sure that we don't cause any issues. And you hit transact. It wants to confirm. We're going to confirm it. And it looks like it's confirmed. So the next step, we're going to want to send our transfer USDC.sol 3 link tokens. We're going to need our contract to have some link to be able to pay the CCIP fees for transferring this USDC across chain. So what we're going to do is we're going to take our contract address, transfer USDC at, then there's an address right here. For me, it is OXFA8E, add a bunch of numbers. Copy this address right here. You'll find a clipboard icon, which will allow you to copy that address. You're going to want to open your MetaMask. You're going to want to hit send. You're going to paste that contract address. You're going to change the asset that you're sending to link. For the sake of this workshop, you're going to be able to do this with just 3 link. So just press 3, no conversion rate available. Then you'll see the estimated gas, the fee, hit next, confirm, and then you'll see that the sending of link is pending. And it's confirmed. So now my contract, transfer USDC, has link. The next step, we're going to want to approve the function on USDC.sol. We're going to want to call the approve function on USDC.sol. So we're going to click this link, address, this Scan Explorer, and this, we're going to want to go into the right as a proxy. And then you're going to want to make sure you're connected. For me, when I connected, it didn't connect until I clicked this approve, and then it allowed me to connect. You might have a different route. It might ask you to connect once you hit right as a proxy, but ultimately you want to connect your MetaMask wallet to SnowScan. For me, you can see that it's connected, and my wallet address is OX4F808. We're going to want to confirm the spender, which is going to be our transfer USDC contract. And then we're going to want to include the value. Now, USDC has 6 decimal places. And if you count here, I have 1, 2, 3, 4, 5, 6, 7 values here. This is essentially saying that we are approving 1 USDC to be sent across chains. But since Solidity or Ethereum does not handle decimals, this has to be done with the decimal system of adding the decimals backwards and going through. So what we're going to do is we're going to then hit right. It's going to pop up your MetaMask. You're going to get this screen. Spending cap request for your USDC. Custom spending cap. This is what you're going to want to see. If you did the right decimals in the last screen, you will see it pop up exactly like this. Hit next, approve, And then once again, if we have any issues with this, I'd be happy to walk through it again. USDC token, 6 decimals, 1 plus 6 zeros afterwards will approve 1 USDC to be spent on our behalf. Click the right button, walk through this MetaMask screen. And then on Avalanche Fuji, we're going to call the transfer USDC function. So we're going to need 4 parameters here. So let's go to that function. Let's close this down so it's a little bit easier to see. Transfer USDC. In this function, we're looking for a destination chain selector, the receiver or the address of the receiver, the amount that we're sending, and then the gas limit. Remember the gas limit when it comes to your homework. The destination chain selector. It's going to be the same value that we added earlier, but it's within our. I'll walk back through it, EIK, in a second. I'm going to copy this over. Destination chain selector 160152. My wallet address. So you can grab your wallet address a few ways. MetaMask. Copy it from here. Or in Remix, it would be at the top. There's a copy account button right here. There's a few different options for you to do that. So receiver, my address, the amount 1000000, so 1 USDC, and a gas limit of 0. I'm going to open up Snowtrace for you one more time, see if I can't unsign it, and then back off. All right, let's sign out. All right, so now I'm signed out. Right as proxy, approve, spender, let's do auto-populated for me. It's going to ask me to connect, verify my account, sign in request, sign in. I'll show you guys again. So sign out, you could sign in on the top right of your MetaMask, or on the top right of Snowtrace, you'll have a sign in button. Click that, it'll pull up this window here. On the top left, you got MetaMask. For me, it says recent. I'm going to click that. It's going to ask you to verify your account, sign a message. When you sign this message, it's going to pop up your MetaMask, asking you to sign it, connecting in, and then you'll see that you're connected. Fernando, Eek, do you want me to walk you through that one more time? I can zoom in as well. I'm going to sign out. All right, so in Snowtrace, sign in on the upper right-hand side of the Snowtrace screen. You see a sign in. Click that. It'll open up a menu. Yeah, it'll open up a menu for MetaMask. Got it. Cool. MetaMask, sign. Go through, sign it again, then you're connected. We can maybe problem solve that with you, Eek, in a little bit. We're going to move a little bit forward. So then we approve USDC to be sent, walk through, you send that. Next, we're on the transfer USDC function. There's 4 values: the destination chain selector, your wallet address as the receiver, 1 USDC or 1000000, and then 0 as the gas limit. You go back over here, you'll see that my transfer USDC function is now populated with all of these values. 06 or 160, then you have my wallet address, the amount, the gas limit. We hit transact. And take a second, confirm this transaction, and you'll see this commit. So then we want to take this transaction hash that we see at the bottom. See if I could zoom in down here for you. Nope. All right, maybe that's good for you. All right, so this transaction hash, we're going to then go to the CCIP Explorer. You actually see my transaction is the second one here as of 26 seconds ago. Is my wallet address is right here, but we're going to take the transaction hash. Nope, wrong button. And you'll see that here are the transaction details. You got the sources finalized. It's elapsed 56 seconds so far. An expected total time of 6 minutes and 12 seconds. That's real nice. Good job. The source chain is the Avalanche Fuji. Destination chain is Ethereum Sepolia. Then your origin came from me. My wallet address came from my contract address of transfer USDC. And then it's going to my wallet address, but on Ethereum Sepolia. You'll see that I spent 0.51 link to send this across, and that the tokens and amount equals 1 USDC. Zoom in a bit here too. Now, let's go. Once you see the success, you have successfully transferred USDC across chains from Avalanche Fuji to Ethereum Sepolia. Do we have any questions from where we're at now? I'd be happy to walk through any of these steps again and help you guys catch up. I believe we got plenty of time. I'm going to scroll through the comments and see if I have anything. It looks like Eek got it to work. You didn't mint USDC. You got USDC from the faucets, and then you had USDC in your account, and you sent that USDC across chains. So you didn't mint the USDC. Yeah. Yeah, you guys have 20 to 30 minutes to practice, walk through this. I will be here answering questions along with if there's anything that I don't know or can't directly do, I'd be happy to pull in one of the Chainlink Labs employees as well. So you just let me know. I'll be here and keeping an eye on the comment section. Good job, Ike. Good job, Patricio. Let's see, who else? All right. So what we're going to do now is if you can share your link to the CCIP Explorer by taking your the link for it and posting it into our YouTube chat, I'll start us off. That way you can see that my cross-chain transaction has gone through, and I'd like to see all of yours that have gone through too. That way I can celebrate your guys' success. Chainlink, maybe we need to import the USDC contract. So what you're going to want to do is we can grab that USDC parameter from our Git book. So the USDC token, we're going to grab this this address right here from our Git book. We're going to open up our MetaMask. On the left side of your MetaMask, you're going to have these tokens. Yours isn't saying USDC. So what you want to do is you want to import your token and you want to paste your contract address. For me, it says that the token has already been added. However, if you have not done this yet, it'll auto-populate with USDC right underneath it, and then a decimal field with 6 underneath that. And then when you hit next, it'll import it, and then you'll see it inside your MetaMask. Cool. No problem, Jim. Just wanted to make sure you got handled. Could you send the link to your transaction, Jim? Maybe we can debug it from there. Jim, post your wallet address. I'd be able to check it from there. No problem, Jim. Thank you. Yeah, sometimes it's a MetaMask thing, and it takes a second to refresh the show. Is it not letting you guys post the contract or the URL? Can we try again? Let's pull it up. All right, so to approve. All right, we want to go to the Snowtrace blockchain explorer. You said that you're not getting anything. You're not seeing the only code tab. So you only have this on the left-hand side here. You don't have admin proxy, proxy implementation, read contract, write contract, read as proxy, or write as proxy. Because we need to hit the write as proxy, and then from there, it'll open up all of these. That's when you connect to your MetaMask with your sign-in. Interesting. Are you signed in to Snowtrace with MetaMask? If it won't let us post URL to the YouTube live stream, we could take the source transaction hash. That will allow me to check it on we could go to Discord as well. Discord's so noisy. There we go. Bootcamp. Let's post our CCIP Explorer into the Bootcamp folder within the Discord. Oh, cool. Thank you, Tabo. Good job. Crypto Prof. Right, professor, but tight. Interesting, Ricardo. Now just to confirm, are you on this link? Hopefully it allows me to post it for you. Try that. It's the same one from the Git book. This one here in step 4. When you open this, Ricardo, did you open it directly from the Git book here? Oh, okay. That might be the issue, because what this is this link is opening us up, not just us to the Snowtrace blockchain explorer, but it's opening us up to the contract of USDC on Snowtrace or on Avalanche Fuji. So we're going directly to the contract address for USDC tokens on Snowtrace for Avalanche Fuji. And then from there, that's why we're seeing the code. And then what's next is the admin proxy, proxy implementations, where you can read the contract, write the contract, read as a proxy, and write as a proxy. So if you would have just opened up Snowtrace, went to Fuji, then signed in, you wouldn't have been populated on a contract address for you to be able to see any of these options as well. So if you go to our Git book, go to the fourth step. Cool. Ricardo, let me know when you write as a proxy, connect in, and you approve your USDC to be sent by the contract. And I'll walk you through this again if you need it. It's been a little bit of time since we did it. But basically, you're taking the contract address from transfer USDC in your remix, you're copying that, you're approving your contract to send the USDC at a value of 1 with 6 zeros behind it. Once you do that, you're gonna write, it's gonna ask, for me, it's asking me to connect. I'm just going to do it for the sake of showing you. Then you write, it's going to ask me to go through this. And then each of those steps are also within the Git book as well. If you're having trouble, everything is very well done in terms of the Git book and resources. I started from a level of very beginner a few years ago, and these Git books have been instrumental in my learning, as they're very well done. You just got to make sure that you pay attention, you read each line, you don't skip anything in the event of just trying to like parse for the most important information. Everything in the Git book is important information. So read it carefully and follow it step by step. And I promise you, you'll get through and you'll make it to the destination. Question on Discord. Let's see what's up. So, investigating on TRX on chain, it states that exceeding approved amount. Got it. So, Dano, you're going to want to approve the USDC to be sent from the contract, because the contract is what's sending the USDC, not you. Awesome. Tight. Daniel, you handled? Looks like it. Ricardo, it looks like you're handled as well. Do we have any other questions? This is fun. Let's go back to CCIP. Maybe get book. I see some of what you're sending, Jim, but I do not see a link. So it looks like it may have been taken out by YouTube. Like, last message I have from you, Jim, is I was able to post a URL here above. Then I don't see a URL. Then I see a, is this what you needed? But I don't see anything else there. I see a thanks, Darby, but no activity. Could be a MetaMask thing. So I can see some of yours. If the ones that I can't see have a URL in it, then it's probably an issue with being able to share URLs, probably for security reasons. Good job, Elias. Way to go. How's everybody feeling about this? I'll get Discord up. Nice. 1 USDC, 3282 link, Fuji, Sepolia, success, sent, tight. Way to go, Lagos. Let's check the other ones. What's going on here? Ooh. Oh, snap. Dang, dude. Got it. All right. SmartCon drummer, way to go, dude. We follow each other on Twitter. Avalanche Fuji, Sepolia, 42 minutes ago. Origin from to your wallet address. Tight. Cool, man. Good job, SmartCon drummer. Let's see what's going on with CryptoProf. Destination change, transaction hash, success. Fuji, Sepolia, 35 minutes ago. 3.39 link, 1 USDC sent. All right. Nando, let's take a look. All right, so we got 0.32 link paid, sent from Fuji to Sepolia. You got a success coming from this contract. And your wallet address, OXCF 80A. 1 day ago, 2 days ago. Way to crush, dude. Lagos. Next. SmartCon drummer, we did you. CryptoProf, we did you. Tebo. Let's take a look at yours. You got a success here. Avalanche Fuji, Ethereum Sepolia, 1 ABC. Interesting. 0.59 link spent in fees. Interesting. I think that's the highest one so far. Hey, let's go. Dano, nice. Sweet. Way to go, dude. All right. Fuji, Sepolia, success on the send. Origin at A2586. 0.47 link spent. 1 USDC sent. Good job, man. Way to go. That was a good turnaround, too. It's earlier. We problem solved a little something, so tight. Tight. Very, very cool. Mohammed's done. Oh, nice. That actually makes sense. Jim Lake, Lagos. Lagos being the Spanish word for lake. I like that. It's a good move, dude. Reese is feeling fly. We can appreciate that. Sweet. This is great. All right, Rick to Central. Let's take a look. Ooh, sources finalized. We'll be there soon. We're gonna sit here and watch. Yeah, so we're waiting. This one's committed now. Source chain being Avalanche Fuji, Ethereum Sepolia being the destination. 0.35 link paid to send 1 USDC cross chain. Origin from DEO24, and you're sending it to DE024024. We're just waiting on a destination transaction hash. We got the source transaction hash. It's committed now. So we're just waiting along. All right, YouTube chat looks like everybody's handled. Do I have any questions from anybody in the YouTube chat or even the Discord? Elevated Prosperity is done. Hey, Elevated Prosperity, have you dropped your transaction in the chat? Or how about Discord? So if you want me, I can take a look at it. Back up, here. This is the one we're watching. It's cool that we got the elapsed time now and then expected total time as well. No community, then bootcamp. Maybe there's a go to roles. All right, so you need to complete verification to join the Discord. So channels and roles, maybe? Yeah, this looks like it. So for me, I have all this going on. I said all of them. I said all of them on both. Oh wait, I got access to everything. So I would check the server guide, make sure that you've read through these rules, useful links, get more info. Maybe there's a check at the bottom. Make sure. I've been in this for now years at this point, so I'm not sure on the joining side of things. Okay, I see what you're saying, Elevated Prosperity. A little Twitter action. You gonna follow us on Twitter anyway? All right, let's see what's going on, young op. All right, so let's take a look. Fail. From here. Fail. Transaction. See more. Nope. You said step 5, so let's go to step 5. Step 5. All right, so in step 5, you're going to want to make sure your destination chain selector is this value. You're going to find that right here for the destination chain selector. We'll make sure that's there. Copy that over. Well, I got too many things open. Give me a second, let me unclutter. Just unclutter. All right, so 160.152, etc. This is the chain selector for the Ethereum Sepolia test network. We're going to copy this, paste that right here. No, wrong one. Receiver. The receiver is me. So I want to grab my own account, my own wallet address, paste that here. You can also grab that by opening your MetaMask. Ooh. Opening your MetaMask and copying it from here. Make sure that's pasted right there. The amount you're going to want to send is 1 plus 6 zeros after it. And then the gas limit is 0. But it's not going to work if you didn't do step 4 to approve the USDC to be sent to begin with. All right. Gas estimation error failed. Error on remix. The fail seems to lie on the transfer USDC contract execution. He did approve the USDC to be sent across, and the account address you used All right, I'm gonna move on. We're still problem solving young op or young Opie, and what he needs. He's got gas estimation failed error on remix. Seems to be happening on step 5. And it looks like he approved USDC to be sent across, so it shouldn't be an issue on the USDC side of things. unless you confirm the USDC to be sent by your wallet and not the contract address, which would be a piece that I would problem solve. Let's go on to this next step here, day 3 homework. So only the participants who finish their homework for all 3 days will be eligible for the certificate of completion. You need to submit your public GitHub repo for the exercise below via this form. You're going to find this in the Git book itself. I'm going to zoom in so it's easier to read for you guys. Hopefully that is, yeah, all right. Following the docs.chain.link, CCIP tutorials, CCIP received gas limit guide, measure the gas consumption of the CCIP receive function. Once you have the number, increase it by 10% and provide a gas limit parameter of the transfer USDC function instead of the currently hard-coded 500,000 or 500,000. You can use this Git book for guidance, and I'll walk through these links, but I'm not going to give any of these answers to you. This is homework. The homework is due by, the deadline is August 25th. Andre mentioned that earlier. I happened to write it down, thankfully. So August 25th is when the Chainlink Labs team will be looking for your completion of all 3 days. If you have your homework completed for all 3 days, then you will be eligible for the certificate of completion. All right, I'm going to walk through these reference links, but I'm not going to give you guys the answers. I'm not going to show you how to do this. That's the fun of it. Yay. All right, so optimizing gas limit settings and CCIP messages. You have this docs.chain.link, all this information. You got to examine the code, gas estimation in a local environment, Foundry, estimate gas, hard hat. You got everything you need in here. Trust me, everything you need for your homework is in this. If you want to use this Git book for guidance, this one is a very similar problem set that you may go through and read and learn. And there's some code there as well. Also, this is a cool masterclass. I remember my brain. I felt like it was one of those big learning opportunities that I came out knowing a lot more and feeling a lot more powerful as a engineer in this space, and understanding being able to move USDC across chains really opens it up from moving arbitrary tokens on test nets or something along those lines. It's very cool to see like real world dollars value, or at least representations of it on the test nets, to show how real this technology is and how much it is going to change everything that we do. So personally, for me, when I first did this workshop, it was like a big moment, like, aha, I get it so much, and was very happy with myself walking through it. For all of you guys that completed sending USDC from one chain to another today, way to go. It's not a small feat. It's fairly simple, but it's not a small feat, and it is fairly complex as well. So way to stick with it and problem solve and troubleshoot through it. And I hope this information arms you for success in the future, because, I mean, we're at like the cutting edge of technology right here. So appreciate you guys spending time with us, me, on this. Once again, your homework is due by August 25th, and that is all 3 days of homework to be eligible for certificate of completion. You can submit your public GitHub repo at this form, and then it'll ask you to input information like your email. It won't let me go any further, but then you have this link for docs, optimizing gas limit settings and CCIP messages. This right here, that link right there is going to be how you'll be able to figure out this problem. Once you fix that problem, you send it off to GitHub, your GitHub repo, and great. You're muted.
Hi all.
There you go.
Darby,
Hello.
thank you so much
Thank
for
you.
this amazing day of cross-chain DeFi. Massive congratulations to you all, guys. Very, very well done. From experience with bootcamps and hackathons, only the real keepers get to the last day. So you guys are the real keepers. So very, very well done for your perseverance and for your desire to learn. And like Darby said, that's how you get to the cutting edge of innovation. So what's next, you might ask? Yes, we have some next steps that we would like you to consider taking. Darbs, if you could go to our next step section in the Git book.
Yeah, let me, there we go.
Scroll it all the way
Got
down.
it. All right. Yeah. No wonder I
Yeah,
couldn't find
there it is.
it.
So we've talked about SmartCon, but there's never enough mentions. So I will say it again. If you're around Asia in October, or planning to go, or you're there already, please join. SmartCon is absolutely unforgettable experience. It's our premier event. It's a lot of fun for builders, for visionaries, for everyone who participates in the Web3 industry. And like we said earlier today, there is Hacker House, and it's 24-hour, actually 40, mind you, 48 of non-stop building experience. By non-stop, I mean non-stop, like through the night. So come have fun. It's incredible. Then, like we also mentioned before, RWA Bootcamp is coming up next. It's at the end of September. And CCIP is one of the primary products that powers tokenization. So you have a great head start to complete that bootcamp as well and learn more about how you can tokenize, what you can tokenize. So this subscription is only available for you now. This event is not public yet, so you will get the front row seat of the RWA bootcamp. And more to stay updated with what we are cooking for you, and there is always something going on. Please sign up for Chainlink developer newsletter. You have a link there as well. This also gets you to the front row seats in terms of what new products we're releasing, what are the updates, what happens in the industry, what happens at Chainlink, what happens with our ecosystem. Also, we have a dedicated page called DevHub on chain.link. So dig deeper into our other products, into CCIP. So it's all there with plenty of tutorials and super helpful information. If you are building something with cross-chain, whether it's in Web3 or an enterprise or capital markets, please get in touch with our experts. So again, we have a dedicated link to get in touch. Please use this. We are always there to answer any questions. Also useful link to CCIP documentation. We are known for having the best documentation in class. So yes, please use that. It's super, super useful and easy to navigate. And general link to our website, chain.link, learn about our platform and continue your education. And again, amazing job. Very well done sticking with it for 3 days. Best of luck with your exercises. Ask any questions you'd like on Discord. We will be there to monitor and answer anything you're struggling with. Darby will be there, Richard will be there, Andre will be there. You saw them, and more of our developer relations engineers will be there to help you out. Again, massive congratulations. Thank you all so much for joining. Enjoy the rest of your day, and we shall see you around. Thank you all so much. Bye.